Hi everyone, this is the first video for section 3.3, multiplying whole numbers. So if you haven't, go ahead and make sure that you've read through this section so that you have seen these things before we talk about them. So just like we did with the other sections in chapter 3, because we've been multiplying whole numbers for such a long time, a lot of our examples will be dealing with multiplying things that are in things other than base 10. So we just remember what it feels like to learn multiplication. So first off, the book starts off by defining the product of two whole numbers by this repeated addition formula. So whenever we're multiplying a number in and a number a, then it's just adding a in times. And yeah, that's essentially all it is. It's just adding things up multiple times. So for example, if we have the product 3 times 2, this is just adding 2 3 times, right? We're adding 3 copies of 2. So whenever we have a product, so for example, if we have that 6 equals 3 times 2, this would be said that 3 is a factor of 6, and likewise we have that 2 is a factor of 6. But whenever we have this, so the things that we multiply together are the factors. And the product that we get, so in the same example, the product is 6, so we say that 6 is a multiple of 3 because we multiplied something by 3 to get 6. So 3 is a factor of 6, 6 is a multiple of 3, and likewise, each of these statements are true if we use 2 instead of 3. Okay, so just like we had properties for addition, we have properties for multiplication, and this makes a lot of sense just because multiplication is repeated addition, so these same properties are going to hold. So again, we are defining all of these for the real numbers. So even though in this section, just like before, we're only dealing with whole numbers, we're going to define this for real numbers because these properties will hold whether we're doing whole numbers, natural numbers, integers, fractions, or real numbers. All of those will hold. Whoops. There we go. Accidentally erased that. Okay, so the first one is the commutative property of multiplication. So this is just saying that if we multiply 3 times 2, right, we add 3 copies of 2. That's the same thing as adding 2 copies of 3, which is 2 times 3, right? So this makes a lot of sense that we can do it this way because we're adding, right? Addition has this property, so it makes sense that multiplication would have this property because we can even expand these out. Instead of 2, well, 2 is 1 plus 1, so we are just adding 6 ones together, and it doesn't matter which way we denote that. Okay, so now the associative property, so just like before, it doesn't matter if we multiply the first 2 numbers and then the third, or if we multiply the last 2 numbers and then the first. It doesn't matter either way. This is going to hold. Next, so before we had an additive identity. So an additive identity was when we added that identity to a number, the number remained identical as it was before that operation. So again, the multiplicative identity is really similar. So it's a number such that when you multiply it, nothing happens. The number that you multiplied it onto stays identically the same. So in this case, 1 is our identity, right? Anything times 1, right? A times 1 equals A for every number. It's the same whether it's on the right or the left. So that's called the multiplicative identity property, is that whenever you multiply this identity onto any number from the right or the left, it doesn't change the value. Okay? So now that we have this different identity, we want to know, okay, well, what happens to that old identity, right? What happened to that additive identity? What does that do in multiplication? So now whenever we have the additive identity, right? Remember the additive identity. Identity. So the additive identity was 0. So whenever we do that with multiplication, that any number times 0 is 0, right? And this makes sense really just from the definition, because we're adding 0 copies of a number. Well, that means we're not adding anything up, right? Or we're adding however many copies of 0 together. Well, again, we're just adding zeros, and that's going to equal 0. So you're either adding nothing or you're repeatedly adding 0, and both of those result in 0. So, right, our multiplicative identity, whenever we multiply it by anything, it stays the same. But now with our additive identity, it makes everything itself 0. So now that we have this, now that we've rigorously defined multiplication and addition, we can, just like how we saw how the additive identity works with multiplication, we can see how addition in general works with multiplication. And we have this distributive law. So we can, when we multiply by sum, it's the same thing as adding the multiplication. So multiplying a sum is the same as summing summing multiplication. Right, so if we multiply a sum, it's the same thing as summing those two multiplications. So we can do this in either order and it's still correct. Let me rewrite this really quick, just so multiplying a sum is the same as summing multiplication. So if this is confusing to you, then you don't have to think about it this way, just showing you how the words kind of relate. Okay, so we have all of these properties that we needed. And so where do these come up, right? Just like before, where do these come up? So just like addition, the commutative property comes up with our multiplication tables, is where we use these. That if we have 1/2, we can just fill in the other half using the commutative property. The associative property really doesn't come up. We use it all the time, right? To show that you can multiply things in any order. So I guess mostly in mental math is where that comes up. So the multiplicative identity comes up often whenever we're dealing with fractions. So when we deal with fractions, we can say that if we want to know what 1/2 is equal to, well, we just multiply by 2/2, which we know is equal to 1. And we can see that 1/2 is really the same thing as 2/4. And so we do this whenever we find common denominators of fractions, which we're going to see later on, that when we just multiply something by the multiplicative identity, it doesn't change its value, but it makes it easier to work with. And then distributive property, we use this again a lot in mental math. So for example, if we were doing 23 times 12, right, this can seem pretty daunting to do in your head if you just need to know what it is, but we can split 23 into 20 plus 3 and then multiply it by 12. So then we get that this is 20 times 12 plus 3 times 12, right? And so essentially all we have to know here is how to do 12 times 2 and how to do 12 times 3. So this makes doing things mentally easier because we can just break it up into the chunks that are easier. Just like how we talked about this for addition, right? We tend to want to break things up into multiples of 5 and 10 just because it's a lot easier to work with those in our head, because we live in a base 10 world where everything is just a lot easier when we deal with 5s and 10s. Okay, so these are the definitions and the properties that we need to know for this section. So next time we're going to look at the different ways to use models and algorithms to actually multiply these numbers. But for now, that's all for this video.